Shanghai GDG is a very interesting developer community.
I'm glad somebody has asked this question.
This is where the magic happens.
This is primarily a question and answer show. So if any of you out there would like to ask questions.
Hi everyone, and welcome to another App Engine Office Hours. So I'm Amy, and with me is Danny. We're both App Engine Developer Relations. And what we're going to talk about today is using Appstats to optimize your app, make it run faster, make it run more cheaply. And so we're using some materials that were prepared by Proppy, who many of you might be familiar with, another App Engine DevRel. So I'll credit to him for these slides. And so what we're going to do is we're going to go through the slides first and give little demos as we go along. And incidentally, we're trying sort of an experiment where I'm mostly controlling the slides in one location in Sydney, Australia, and Danny is doing a bit of controlling of the slides in another location. So you may see me sort of like roll my eyes to the side as I'm going through these slides as we try to coordinate. So what we're going to do is we're going to go through the slides first, and then we'll go to the moderator queue. And we're not able to invite people to join live this time. And so what we're going to do for next time is start gathering Google Plus circle of people that want to be invited to these Hangouts, which will make it a little more organized. So watch for posts about that, both on Google Plus and on the App Engine group, and we'll start gathering a list of interested people so that it's really smooth to invite you next time. So this time we're just going to communicate with you through the moderator queue. Sorry about that. So go to the GDL event page where you found this, and you should see the link to moderator queue there, and add your questions there. Okay, so let's get started with the demo. And first, I'm going to give just a little bit of an introduction about Appstats. So most of you are probably familiar with Appstats already. And just in case you're not, let me just give a little plug as to how useful it is. It's available for both Python and Java, and it essentially lets you see a bunch of things about how your app is running. It lets you see where you're waiting for network calls, figure out what RPC calls are costing you the most, maybe notice where you're making repeated RPC calls, say to the data store rather than when you should be doing caching, all sorts of useful things. So what we're going to do is we're going to use Appstats to show some what you might call design patterns and anti-patterns, which ways to design your app and not so good ways to design your app that really make a difference with efficiency. And we'll be able to see this with Appstats. Okay, so this is all covered in the documentation, but just a little quick overview of how to set up Appstats for those who aren't familiar with it. You first have to set up a so-called event recorder in App Engine config, and then also in App Engine config, you can set some configuration variables that impact what gets tracked. And so in particular, one thing we're going to do for this broadcast is we're going to play around a little with Appstats calc RPC costs. So we're going to be setting this in our config file. And you can look at the sample config file if you want to see some of the options that are available. Okay. So, and then once you've done that, you need to essentially, in your app.yaml setup, you need to tell your app where to find Appstats. And the easiest way to do it is just the default. Use this built-in specifier, and if you do that, then you'll find Appstats under _ AH/stats. Okay, and then there's something that's new to the recent App Engine release, which is really very cool, which is an Appstats shell. So if you configure this, it basically brings up a nice little interface where you can run arbitrary Python code. And so we're going to use that during this these slides during this demo. And so it defaults to false in production. You don't really want this on, just sort of arbitrarily, but we've turned it on for this demo. And the flag that's shown here is how you turn it on. So we put that again in AppEngineConfig.py. Okay, and before we get started with our patterns and anti-patterns, I just wanted to put in a brief plug for something new, the Appstats Analytics. It's in trusted tester phase right now. And what it is, it's something that essentially builds on top of Appstats, and it's an interactive visualization tool. It lets you drill down into all sorts of data really nicely. It's great. And if you're interested, you can sign up for it with the link shown here. And so these slides, so you don't have to scramble to write down the link, these slides themselves are linked to in the GDL events page, as many of you have probably already discovered. So you can go find the slides there and get the link. And please do sign up. It's really neat stuff. Okay, so let's do a few little demos. And here's where Danny and I have to try to coordinate. So we'll see how we go. Are you ready, Danny?
I am.
Okay. One common mistake that people make that sort of slows them down sometimes is they do a query to get an entity from the data store when they could just be fetching directly by the entity key. And before I go further, I should mention that for these examples, we're using NDB and Python. And if you're a Python user, I would really recommend checking out NDB, which is the more new of the
data store
APIs supported. Sorry?
I said data store APIs.
Yes. And it has a lot of nice characteristics that the other one doesn't, including things like asynchronous puts, transparent cache management, really nice transaction management, all sorts of stuff. So I'd really recommend that you try it out if you haven't already. And Danny, please break in at any time as I go through these lines. I can't actually see Danny. You'll see me like looking over sideways. I can't actually see him, but I can hear him.
So
all right. So
I did want to point out this particular model also does not use one of, in my opinion, the best features of NDB. Sort of its secret sauce. It doesn't use Memcache or the local cache of the instance handling the requests for actually caching the data. So you see those variables on user, the attributes, that is _use cache equals false and _use memcache equals false. And that by default turns off those two intermediate caches and goes directly to the data store. So this is really a slide about the data store itself. So I just wanted to point that out, Amy.
Yeah, thanks. That's an excellent point. We turn those off just for demo purposes so that we can see the RPC calls. Normally, you would not want to do that. So we should make that very clear. Normally, you would not want to turn off the caching. You would want to leverage it. It works really well. Right. Yeah, so thanks. Very good point. We're only doing that for demo purposes. Okay, so what we're doing here is we're and I won't go through the code in gory detail for each slide because that would take too long. But essentially, the gist of what we're doing here is we're doing a query based on the name field of the user. Okay. So Danny, click the run button there.
And there we are.
Okay. So what we're seeing here is the shell, the new shell, and I won't go through the pieces of it in detail for each of our little examples, but just to sort of look it over at first. we're seeing a timeline, and we're seeing how long the RPC the RPC calls each call in the little code snippet, and then the total. We're seeing the grand total of how long our little code snippet took to run, and we're seeing RPC stats. So Danny, I think you might have to switch to
Will do.
the RPC stats tab. I'm not sure.
Yep.
Yeah. Okay. Yeah, and that I'm not seeing on on my slides, but you can also see the cost, the so-called cost for each RPC call that you did, which is new and which is really cool. And up at the top right, you'll see a little explanation of what these costs mean. And so, as everyone might remember, it's there's this concept of small data store operations versus more expensive reads and writes, and so we'll see that in these two examples, this one and the next one. So here we did a data store query. All right, and so sort of make a note of what all of this cost. All right. So now switching back to this.
Amy, if you can't see it, the query itself cost 140 micro pennies. And the put itself costs 600 micro pennies, and those consist of 2 reads for the query and 6 writes for the put.
Okay, thanks. Yeah, I actually can't see it.
Okay. So you want to head back to the slides?
Yeah. All right. No, I think we're having hold on just a second. I think we're having a bit of a fight between our two.
Oh, yeah?
Yeah. Sorry, everyone. We tried to do something fancy here with remote slide advancement.
Yes.
Oh, okay. So are we on...
Slide 10.
Okay.
Now we're on slide 9. Now we're on slide 8.
Okay, I think you'll need to advance the slides, Danny. Sorry.
Okay, no problem.
Okay. Hold on 1 second.
Sure thing. So what we're seeing here, the answer to the anti-pattern that we just saw, rather than actually explicitly doing a query, we're going to be able, as Amy said, to look up directly from the ID. Since we set the ID when we create the user object that we're putting in the data store, we can actually go ahead and use that ID and query directly by that ID. So Amy, do you want to take the reins, or are you still trying to figure
yeah, so
out?
I've just for Danny's benefit, I've switched to a different version that won't be tracking with yours, so you can advance the slides.
Okay.
Yeah. Okay. So the right way to do this then is to do a get by ID, and so this is if you have the key to your entity, be sure to fetch by that key and not by doing a query. And so this is both cheaper, it's a smaller data store operation, and it's faster too. Okay, so Danny, do you want to show the results for that?
Wow. So we see here in the RPC stats, instead of 140 and 600, the cost of the get is 70, and that's because we went from 2 reads to 1 read. and the cost of the put is only 100 instead of 600, and that's because we've already put that ID before. That's not anything special. This is really an anti-pattern about queries, not about puts. Is there anything else you'd like to point out about this, Amy?
No, that's a nice straightforward one. Remember to always fetch by ID if you have the ID, and it makes sense for your app.
And so what's happening under the covers, before we moved on, I just want to point out, if you call getById on the actual data class that you've defined, so here user.getById, what that's doing is, under the covers, it's explicitly constructing a key, and then it's just making a query to the data store from that key. So it's a nice class method afforded by NDB models.
Okay. So advancing to the next slide, Danny.
Yep.
Just sort of explains why. Essentially, recapping what we were talking about. Queries require more RPCs and they're more expensive.
Yep.
All right. So anti-pattern number 2. And this is a good one that's easy to forget to pay attention to. Don't use index properties if you don't need to. And so as most of you probably know, each one thing that makes the data store so fast and scalable is the way that it uses indexes. And each time you create an entity and save it or update it, it requires some index operations. And the particular indexes that need to be updated depend upon your essentially upon the types of queries that you are making on your data, which in turn is specified in an index.yaml file. So the number of index writes that you need to do for a given entity can depend upon how you're using that entity, but it can be a significant part of the expense of creating or updating an entity. And so one big key to managing this expense is you don't need to index every field if you don't need to query on it. You might often have entities with only a few fields needing to be queried on, and a lot of them just there to persist the data. Okay, so the default is to essentially index everything. And so here's an anti-pattern, number 2, where we're not really paying attention to our indexes. And then if we go to the next slide, here we're showing the same model, but we're saying for the secret field, indexed equals false. So we didn't do that before, and so the default was to index it. If we say indexed equals false, then we're not creating indexes for it. It makes our writes cheaper, and it makes them faster. And so, sorry, Danny, I forgot to do the demo of the indexed one first. So let's go back a previous slide and show how costly it is to...
For the anti-pattern.
Yeah, to do a write when we're indexing the field that we don't need to.
I'm not sure. I'm getting some sort of... the Chromebook doesn't like it.
Oh, no.
This is interesting. I think there's an iframe that it doesn't want to be iframed or something. Let me reload the deck. Sorry, folks. This Chromebook is not my computer, but it is the one I'm using right now. What in the world? How do you right-click on a Chromebook? There we go. I don't know why it's not loading. This is unfortunate. So it's like there's an... Oh, okay. There we go. Let's try it again. Huh. I don't know what's happening, Amy. It seems like... Well, let me just copy the code and I'll run it.
Well, and the slides are online, so if we end up having some technical difficulties here, we can just page through the patterns without trying to do the demos if we need to, and you guys can play with that yourself as well.
Yep. All right. Oh, same issue. It's there. It's just behind this thing.
Essentially, each of these slides, when we click Run, what we're doing is we're doing a post to the Appstats shell URL.
Yeah.
And so you guys will be able to play with this yourself with the given slide URL that's in the GDL event.
I think what just happened there was that the code was too big and it tried to grow the text area beyond what the screen wanted. So I just deleted it because Chrome lets me do that.
Okay.
Yeah. So breaking down what happened, since we actually had to create this index property, we had to do 9 writes to the data store. So there were puts that happened at 2 different times, and that's because we put the object twice. So let's run the other one. Let's hope this one doesn't give us this big white object. Okay, let me delete that again. Sorry, folks. Okay, and this one, there were only 3 writes because we didn't have to actually create the indexes. So there's that demo after a bit more effort than we anticipated. But that's the point of a demo, right? The demo gods hate everyone. So Amy, do you have anything more you want to say about data store pattern number 2 before I move on?
No, move to the next slide where there's sort of a recap of that.
Yep.
Yeah, essentially, just as we were saying, there's a lot more going on when for each index property. You have to do 4 writes to plus another one to essentially create the indexes for that field. And so, anytime you do not need a property indexed, remember not to set it to be unindexed. The default is that it's indexed, so unless you pay attention to this, you won't get the savings. Okay, let's move on to anti-pattern number 3. And this is a neat one that highlights something that's relatively new in terms of App Engine. Yep. So don't query full entities if you don't need to. So you'll often have situations where you don't need to grab all of the fields of an entity that you're querying for. And so here's a situation where we are grabbing the full entity, first of all. So we're just doing what you might think of as sort of a generic vanilla query where we're getting our user objects. So Danny, why don't you first show the cost for that?
Okay. Ah, wonderful. It didn't break.
Very good.
Yeah. So the stats themselves for the RPC, we have 2 writes, which cost 200 micropennies, and 3 reads for 210 micropennies. Is there anything else you want to point out? The timeline or any particular order of those guys?
No, nothing in particular. No, okay. We'll get to ordering in just a bit here.
All right.
Another neat feature of NDB.
Yep.
Okay, so moving on to the pattern number 3. What you should do instead, if you don't need all of the fields in your entity, is do a projection query. And we actually had a hangout the other day on projection queries as well. They're pretty cool.
Yeah.
And so the syntax is different for each data store API. So this slide is showing is slightly different. The gist of it is the same. This slide is showing the NDB syntax. And so we're doing a projection on email. So we're saying for our purposes of this query, we just need to get back the email field of each of our objects and not all the other stuff. And so the query, when entities are returned, they're first of all they're cheaper. They're small operations like keys only fetches in terms of cost, and they're quicker as well, typically.
Yep. So you want me to run it?
Yeah.
Alrighty, so let's see it. So our cost for the puts has that's sort of unimportant, but when we're the number of RPCs we actually need for a run query. So actually, the cost didn't change. Do you know why that is?
No, I don't.
So I guess it's probably likely that it's not the actual cost of the RPC that changes, given it's relatively the same amount sent across the wire as a protobuf, but it's the amount of time to actually get it sent. So
yeah, these entities are so small that the amount of the time savings is probably negligible.
Right.
The RPC operation should have been cheaper.
Okay.
However, yeah.
Okay.
It should have been essentially a small operation.
Right.
Cost. Yeah.
Let's run it again and see. Yeah, we're seeing the same thing.
So if we go to the next slide, which just talks about why this is. Essentially, projection queries only fetch the projected fields, and they're small reads, as we were just talking about. So if it'll be cheaper, and while the time savings might be negligible for relatively small entities, it can also be a lot faster as well.
Right.
Yeah. Now, one important thing to mention, and with our projection queries hangout, we did go into this in a little more detail. The indexing requirements for projection queries are different. I won't go into the details here, but essentially, you, depending upon the nature of your queries, you might need to have more indexes defined if you're doing projection queries than you would for non-projection queries. It depends on the nature of what you're querying for. So it is possible that if you switch to using projection queries, your writes can be more expensive if you're needing to build more queries, but your reads should be cheaper. So it's kind of a trade-off that you have to analyze. And it's not necessarily given that you'll need to define additional indexes. It sort of depends upon what kind of queries you were making previously.
Sure.
Okay. Anti-pattern number 4. Don't use an offset. And so this, if you're looking at how to page through your data, you might have seen mention of query cursors and offsets. And offsets are, in a sense, kind of the simplest or most straightforward model. What you're saying is start giving me data from a given point. So, for example, in this slide, we're saying we want 10 pieces or 10 entities, but we want starting at offset 10. So, starting at entity number 10 in the list that would have been returned. And so this is often a really straightforward way conceptually to page through your data, because you're saying, I want to start here and I want to get some number of entities from this point. Okay, so why don't you go ahead and run that query, Danny?
All righty.
Turns out that this is not, this can be the non-optimal way to do it for reasons we'll talk about in a minute.
Okay.
This might be another case where it's relatively simple and we don't see much of a savings for this particular example. But we'll talk about why in general it can be a bad thing to do.
Right. So the writes, not so much important to note here. We see 80 writes, but that's because we populated 20 entities called Heidi 0 through Heidi 19. Or those were the keys, excuse me. But the reads are what we want to take note of. So we see here 32 reads. And that's that's a result of, as we see, first querying the first 10, and then of course getting the second 10. And we'll explain a bit of the differences after we see the actual pattern. But 32, that's your magic number.
Okay, so let's look at the what's often the more preferred way to do it, and then we'll talk about why that is. Often it makes more sense to use a cursor. And the way a cursor works is when you do a query, you can request back a cursor, essentially a pointer to where you were in the query, and you can use that for a subsequent query. You can say, start from this point for my next query, and you pass the cursor back into the subsequent query. So that's what we're seeing here. We're passing in the start cursor. So instead of using an offset, saying start at entity 10 or start at entity 100 or whatever, we're getting a cursor when we do the query, and then we're passing it back into the subsequent query. Yep. Okay, so why don't you run that one, Dan?
Yeah, let's see it. So looking at the stats, instead of 32 reads, we have 22 reads for queries and 1 read for next. And next is a query, a read that we haven't seen yet, right? So this is actually unique to cursors and paging. But that is, sort of the gist of what we want you to see here. We went from 32 to 22 plus 1 extra next read. So what are the implications, Amy?
Okay, so move to the next slide. So why is this? Essentially what's going on is that when you use an offset, you're still essentially fetching the results, even the first 10 or first however many. Just you're discarding them, but you're still needing to fetch them. And so it's a lot more expensive. And that is amplified if your offset is, say 500 or 900 or something like that, rather than just 10. So much better is to just use a cursor, and that doesn't require additional results to be fetched and then discarded. You're essentially saying, I know exactly where to pick up where I left off. Here's the point. No extra fetching needs to be done. And so it's faster, cheaper, less bandwidth. And the data store has the concept of a reverse cursor as well, which I won't go into the details, but essentially it makes it possible to do pagination in both directions using a cursor rather than needing to use an offset.
Yep. Great feature. I love it, actually.
Yeah, it's very nice.
It's even helpful if you have created a bunch of entities and you want to delete them all in a way that's failover proof. You can pass cursors from process to process rather than actually trying to do everything in place if you have enough. But that's a talk for another day.
Yeah, in general, it's a much better thing to do than to use offsets.
Yep.
Okay, so anti-pattern number 5. Okay, and now we're finally talking about Memcache, which you might have been wondering where the role of Memcache was in all of this optimization. So essentially, don't do a fetch from the data store if it makes sense to put your entities in Memcache and get them from there. And so here, I don't think we need to run this again necessarily. This is essentially what we saw before, where we were doing a direct fetch of the entity by ID. And so let's go to the next slide, the pattern number 5, where what we're going to do is fetch the object once and then store it in Memcache. And we won't go into the details of what we're doing to do that. In this case, we're doing we're essentially dumping it as a JSON string. There's other ways that you can do it as well. And then later on, if we need to fetch that object, the first thing we do is check if it's in Memcache, and only if we don't get a Memcache hit do we actually fetch the object.
Yep. And
so there, as many of you watching this probably know, you're probably thinking, well, there's all sorts of, that's a little oversimplified, and there's all sorts of things that you have to pay attention to when you're using the cache. And so happily, NDB actually does in fact do a really good job of managing the cache for you, so that if you use NDB, you don't need to write this code yourself. You just need to use the NDB cache. So you would in fact not set the those use cache and use Memcache flags to false, like this example slide is doing, and you would let Memcache manage it for you.
Yep.
So
shall I run it or shall we move on?
Yeah. Yeah. Why don't you go ahead and run it real quick?
All right.
Yeah.
Well, let's see it. So we actually have only one data store write coming out of this because the other calls, the other RPCs, are Memcache RPCs. We have a Memcache set from the top and a Memcache get when we try to make that retrieval instead of hitting the data store first. So we just have one write to get our object into the data store, and we have no other data store RPCs.
And as we were just talking about, the same will happen if you use Memcache and don't set those flags to false.
Yep.
I think maybe we'll skip showing the demo of that since we're running a little short on time. But it's essentially the same. And do you want to show it, Danny? It's kind of neat how NDB manages it.
Yes.
But,
we may not even see it hit Memcache. Okay. Yeah. So we only see it hit. We only see it set Memcache. We also see a call to delete Memcache because it's undoing what the previous one did. It's invalidating the cache. But we never see memcache.get because in this particular slide, we're also using the local cache on the instance. So it never even needs to read from Memcache because getMyID will automatically read from the instance.
Yeah, and that's in fact something particularly nice about the NDB caching model. It'll use instance memory where it can, as well as Memcache. It's very nice. Okay. And then the next slide just sort of summarizes this. Reading from Memcache is faster and cheaper. And then instance memory, which again NDB will manage for you if you let it use its defaults, is even faster and is free.
Yep.
Okay. And so finally, one more really nice anti-pattern. Don't do individual RPCs when you have to. Okay, so first let's just run an example where we are doing individual RPCs, and by that we're doing 100 puts, each one after the other. So.
And it is taking a long time. So the emphasis here is not that we're going to be hitting the data store any less. It's really the amount of time spent hitting the data store, right? So we see this giant cascade. Most of them are pretty quick, on the order of 20 milliseconds, but every once in a while we have some extra latency. So we had a 139 and 172, and then it kind of gets long, right? So as we go down this cascade, we're even as bad as 483 at some time. So our total time, our grand total, was 6,674 milliseconds. So almost 7,000 milliseconds to actually put all 100 of these in succession, and they're all blocking puts, so we can't get to
one
the
after the other.
Yep.
Yeah.
That's why we saw that cascade.
Okay, so you might be thinking, well, do they really have to be put one after the other like that? And no, they do not. And this is another thing that NDB makes very easy. So let's look at the next slide. How can you batch these? And it's very straightforward. You do a multi-put. Put underscore multi is the actual name of the call, and it's really straightforward to invoke. We're just passing put multi a list of all of our new entities. Okay, so let's take a look at what that does.
Yeah, let's see if we see a cascade still or something completely different. So rather than 6,600 milliseconds, our grand total time, 457 milliseconds. So it's a complete turnaround. And we do see an RPC total of 2,019 milliseconds, and that's a different statistic, and I'll let Amy talk about the difference between RPC total and grand total here. But the big turnaround we want you to see is 6,600 to 457 on the grand total for the RPCs. So Amy, back to you.
Okay, yeah, so let's moving to the next slide, why is this happening? So essentially what multi is doing is it's batching the writes and it's running them in parallel, essentially. And so it's a lot faster, and the grand total time is much reduced. You're not blocking. You're not doing the RPCs individually, and you're not blocking. And it is you are still charged for all of your writes in the same way. So you're not seeing any reduction in terms of those costs, but it's a lot more efficient.
Yes.
And you can use this technique not only with data store, but Memcache, task queue, full text search API.
So it's still the same cost for your data store operations, but you no longer have the cost of a poor user experience, right?
Right. Okay, and one more real quickly. Yet another great feature of NDB. So I'm probably sounding a bit like a broken record, but NDB is great. If you have different RPCs calls, you don't have to essentially do them all synchronously in sequence. And let's skip running this one, Danny, because we're running a little short on time.
Sure thing.
So move to the next slide. How can you avoid running them in sequence? You can use something that we don't have the time to go into in detail here. You can use the concept of futures, where essentially you're essentially spawning off all of your calls. You're saying go do your stuff. Don't block on waiting for the result. And then when you're ready to use the result, at that point you can say, all right, now I'm going to wait until all these calls have returned. So what we're doing here is we're starting the first URL fetch, and we don't need to wait for it to return before we start the second one. We don't need to wait for either of those to return before we start the first one. And there's an analog that I don't believe we have a slide for data store operations as well, which is a put async, which does essentially the same thing. So this is showing RPC calls that don't access the data store, but there's a put async variant for accessing the data store in the same way.
Okay.
So the concept is basically start a bunch of operations, and then you can do some stuff in between. Then when you need them to have all be done, then you can synchronize and wait for them all to finish. Okay. And why do this? Well, latency depends on the slowest async RPC. So it's good to do as much other computation as you can while you're waiting for the I/O. All right. Anything you wanted to add, Danny, before we sort of wrap up and go to a few questions?
I did just want to mention that using futures is a great feature of NDB, but URL fetch also has fetch async already within that API.
Yeah.
But you have to sort of write your own wrappers around it and figure out your own ways that you want to wait on a lot of things. Whereas if you just if you use NDB futures, it's just kind of done for you. So.
And applicable to other things other than URL fetch.
Oh, certainly, certainly.
Yeah. Yeah.
Yes, that's a special feature there.
Yeah. Okay, so just kind of wrapping up with this, then we'll have time for a few questions from the moderator queue. There's a related recent Google I/O talk that's linked to in the slides called Optimizing Your Google App Engine App. And it doesn't make the same use as the Appstats shell as ours does. It has a little bit of a different focus, but it covers a lot of these same concepts and more. Goes into some of them in a lot more detail, so I'd really recommend it if you're interested in this kind of thing.
Mm-hmm.
Okay. And then other things that we didn't have a chance to mention include things like making use of the task queue. You don't have to do everything synchronously with your user-facing requests. You can offload a lot of things. You can take advantage of the instance scheduler behavior to sort of control, essentially control things related to how soon your instances are, basically how many warm instances you need, how long you wait for an instance to be available before you start up another one, all sorts of stuff that can have an overall effect on your application latency. And so that's a topic for another Hangout.
Sure.
Yeah. Okay.
Yield,
and again, many thanks to Proppy for creating the original version of these slides.
So I'm going to stop sharing the screen for a bit, and I'm going to get the moderator queue pulled up. Give me 1 second before I do that. Amy, if you already have it pulled up, or if you have a question from it off the top of your head, feel free to go ahead and start answering.
Okay, I do have it pulled up. And let me just say, I think we ran a little longer than we meant to in the presentation. Sorry about that. So for those of you whose questions we don't get to, we will post responses in the moderator queue. So look for it there. So let me start with an easy one, or at least easy in terms of how I know how to answer it. Will we ever be able to run App Engine apps on our own servers? Sort of like a dev app server meant for production. And so this, for that, I would recommend you check out something called Appscale, which is quite an interesting project, and I'll post the link here in the moderator queue, which essentially does that. And I've never tried it myself, but it's a really interesting research project, essentially. Really cool. So Appscale. All right. Let's see. And then there's a question about calendar events, which we've also answered in the moderator queue. The short answer is, yeah, there are ways to find these events.
Hold on a second.
Okay. Do you want to pick one to answer, Danny?
Yeah, sure thing. So there was let me find the exact text of it. Let's see. This is a question about testing. Yeah. So somebody is testing with TestPed, and they're wondering if there's a way to disable some stubs, or how they can actually enable a logged in user. So I'll just say, if somebody wants to check out the actual, I think it's google.appengine.api.users module, there's some functions in there that actually allow you to work with users, right? And there's one in there, users.getCurrentUser. And all the source in that does, it actually tries to read some environment variables. And so in Python, you can get them by calling os.getEnv or trying to actually use the os.environ dictionary. And they set various things like user is admin is either a 0 or a 1. User ID is set to some number. User email is set to some value, right? And so if you're testing, you can actually set the environment variables yourself before you're running those tests. And so all these sort of App Engine functionalities which take advantage of identity are then just going to go ahead and use those environment variables. So you actually don't have to worry about a stub. You can just set the environment variable. It sounds like this particular person is familiar with certain things like data store subs and other things for doing testing. But if you're not, we certainly welcome more questions, because testing is important, right? So
okay, and let's answer one of the App Engine specific, Appstats specific questions here.
Yeah.
Let's see. There's one question, when you use the batch APIs, the batcher under the hood spins up multiple RPCs. It's from Jason. While this performance optimization is welcome, it makes the Appstats visualization very busy. Yes, it does. Any thought as to how you might group RPCs better? So I think that is part of what the new Appstats analytics essentially layer on top of Appstats is trying to address, at least to some extent. So different ways to drill down into your data. And so if you're not already a trusted tester for this, please do sign up and take a look. The Appstats analytics are at a stage where we're really open to lots of feedback about how it could be improved or what you're seeing that works or doesn't work. And so we'd really appreciate the feedback on that. It's sort of an attempt to get at some of these issues. Okay.
So another question from Jason that I'll answer briefly about the stack that we saw in the cascade, and he was asking about why they were getting longer on the request as you were getting further along, and there are various reasons for this. Latency is never a guarantee, right? You don't know where the actual data center or any other particular physical location of the machine is, right? But also, if you're hitting an instance and you're hitting the same instance with more and more requests, then latency can increase because there's less memory. In I believe the application we were running was multi-threaded. So as more requests hit the same instance, it gets spread thinner and it's not able to address things as quickly. Do you have any other remarks about that, Amy?
No. Mm-hmm.
Okay, cool. Do we want to...
Let's answer the question from Bryce.
All right.
Which got a number of votes there. Although I'm not sure if I can answer it to Bryce's satisfaction, but we'll give it a try. Will the CPM USD number in app logs eventually reflect the cost reported by Appstats? Is it relevant? So my understanding, and Danny can correct me if he knows differently, is that yes, it is relevant and is intended to, it reflects reality, and it's based on underlying calculations that are tied to what actual charges are, and so the RPC cost reported by Appstats, I believe, is a subset of this. So that's why they don't exactly track. But to my knowledge, it is relevant and intended to be accurate. Danny, do you have any further?
I can neither add to that nor contradict it. So good answer.
Yeah. We can follow up and post more information. But yeah, it should be accurate. Okay. Let's go to a question from Gary. Which,
okay.
And we're almost running out of time.
Yep.
Yes, we are. So sorry, everyone. Again, we'll anything else we'll post responses to in the moderator queue, and next time we'll hope to invite more of you into the circle so you can actually chat with us directly. Okay. So one last question from Gary. What's the best cost-effective, scalable, etc., design for a sensor Internet of Thing kind of application? Some of the constraints are real-time responses based on time window of data, maybe using backend's memory, push queue, or channel, and also map-reducing historical data. Well, that's a very broad-ranging question.
It is.
And maybe I shouldn't have tackled it just as we were about to run out of time.
I'm not entirely sure I understand the scope even, though I do like that he wants to use all these features.
Yes. Yeah, I guess some general, in terms of making things really scalable, some general pieces of advice would be lots of use of in-memory caches and backends can often be really effective. You can get, depending on what you're trying to do, you can get some big backend instances running. They can stay up for a long time, and they can hold a lot of stuff in their cache, and that can be a really low latency and an effective way to do things. And
they can also run computations much longer than standard tasks.
Right. Yeah. So backends can be really good for both long-running computations and things where you have some sort of sensitivity in terms of your latency. If And of course, task queues are really good for being able to offload as much as you can. Anything that doesn't require an immediate response, if you can offload it to a task queue. And again, those task queues can run on backends if you need them to. That can be really effective as well. Yeah, and I'm sure Gary, who's from Sydney, I think we'll have a chance to talk about this at some later point. So I look forward to chatting with you more about this later. And on that note, I think we had probably better wrap up.
All right.
We're a few minutes late. Sorry, everyone. Yeah, so see you next time. And again, we'll get more of you actually in the Hangout next time.
All righty. Thanks, everybody.
Bye, everyone.